Are we live? Am I live? Hello everyone. I'm glad I'm back with you people. We have Sniff, Alex, Tiny LED Matrix, Fruchtzwerg, Johnny, Andy, Lars, Quindor, Hafgenside. Oh, there is something missing. Title fondue cam. Yeah, here we go. How am I doing? I'm sorry. I was on vacation hiking, or it was in Bavaria, and I did some mountain hikes, like day trips, and it was cool. We had great weather. We also visited Munich, and yeah, it was my first time in my life in Munich. We were visiting the brother of my girlfriend. Oh, volume? What? What are you talking about? I'm at -10 right now. I'm really sorry that I'm not one of the YouTuber that clips audio all the time. Hello, Aaron. M40K, hello. No, it's not hitting the red, it's hitting the yellow. And the yellow should be okay. Am I posh? What? Okay, so I came back from vacation. My home wasn't burgled after I doxed myself, but yeah, my post box was overflowing with stuff from China, and an Amazon packet that I got from André Fiedler. Thank you very much. The message is 10 hours stream, or 10 Stunden Stream ohne Fondue kann ich nicht verantworten. So he can't verantworten, what's the word? So he can't stand me having a 10-hour stream without having fondue. But it wasn't cooled. I don't know if this is a special kind of, I didn't open it yet. It was like one week in the sun, because my post box is on the like south side of the house, and it was like sticking out the post box. and I hope, since we had good weather, that it didn't spoil. Let me just open it. So thank you for the present, André. Make it go slightly into the red. OBS scale weirdly. Okay. Yeah, no, it's maxed out in OBS. I would have to like increase it on my road, and I really don't want to mess with it right now. I could switch the microphone, but then you will get more echo. How do you like my shirt? Usually nobody would use a white shirt on stream because it's like blown out. Any fart bombs? What? No fart bombs. Budin, hello. Okay, so let's open that first, that fondue, so we can check if it's spoiled in the sun. Maybe I should set up like a Amazon wish list, even although I really don't want to use Amazon too much, because oh wow, Swiss style fondue. That's a huge packet. Does it need to be cooled? I hope not. Oh yeah. Vor Wärme geschützt und trocken lagern. Okay. I hope it was windy here. Then it was maybe cool. Yeah, I will eat it anyway. Oh wow. Oh, it's 2 packets. Yeah. Score. Moldy fondue, nice. No, I don't throw away food. That's one key feature of bitluni, is that I as long it's somehow edible, I don't throw away food. I can't like let people die from starving somewhere in the world and then throw away half a plate of food or something in the restaurant. So I rather stuff myself. But that looks good. I will open it and we will take a smell test. So maybe I will set up. No, it's fine. I think this is good. Oh, there is hair in my pot. I had this pot, of course I had this pot on the vacation. It was with friends and we were 7 people, but we had some vegans there. So yeah, and we had fondue one day. So the vegans had vegan fondue and I had with 2 other people had this fondue, and we put in the pot like 3 packets, but apparently it was way too much and I had to eat like fondue for 3 days. So after that I thought I wouldn't eat fondue for weeks, but now that I came back and there was fondue in my post box, it's basically happening again. So here we go. The video looks choppy. Maybe I should disable few of the inputs. Yeah. That was, I think that was the other input. It's in 4K. So either this camera or the other one. Enjoy the last 3. Local host. It's not choppy? Okay, yeah, it's only displaying choppy for me. Okay, great. I had plenty of stuff in my mailbox. So I ordered at Eisler the boards, because Eisler is a new sponsor of mine. And they are manufacturing the boards in Germany. There are other like places, they also manufacture in the US and so on. And how high was the cost? You saw it, how I tested ordering it. So one of the boards has a like smeared silk screen here in the center. So that's an issue. And of course the typical Eisler mouse bites. So they basically put all the prototype orders in on a huge panel with others, and I don't know how they cut it. But other than that, I wasn't able to use like gold plating for the Flippy Flip. Okay, fondue, chill out. Fail not working. Oh, fail is turned off. I had to turn off everything since I was gone, but I can turn it on again. Let me switch the cables here. Oh, I'm always rolling with my chair over the cables. I should replace this chair with another without rollers. Where is I need no. Oh, and I need to update the stream again. Okay, no fail today. Sorry, no fail. Let's not waste time with the fail. I think Iceland is made in Czech Republic. They have Czech Republic and Germany. I saw it in the list. I can maybe you can see there is like a list. If you want like the express, you can order like gold, and the capabilities are a little bit different. It's made in Czech Republic, but also in Germany. That's why I ordered it on Monday at 11 a.m. and it arrived. They shipped it on Friday, and it arrived on Saturday without express shipping. So I saved a little bit on the shipping costs and got it within 1 week. Of course, I was gone on Thursday already, so I wasn't able to receive it, but the timestamp on the postal was Friday, and usually I get it no matter where from in Germany. I get it within 1 day because my location is like the center of Germany. VGA madness in the background. Yeah, it's still sitting there with all the other stuff. I received other stuff as well from China. Okay, so I got to populate this thing. I ordered like sockets, many sockets in different sizes, 3 different sizes of sockets, ICs. So apparently it's easier to get DIP ICs now. It was a different way a few years ago, but now everything that you can put in mobile electronics is like unavailable. Optocouplers and other ICs. I even have like a 4-pin DIP socket here for ICs. And like this is a MOSFET, and we got screw terminals. These go like here. ENIC is Czech. Yeah, that's why shipping takes longer. No express shipping with ENIC. 10-pin or double leaf. Hello, Christos. Okay, so one thing that I also saw is that I don't know if this is like simply because I must pause this here. Maybe you can see it. The wires, I can see through the wires. The wires are not plugged. So I googled that KiCad has no way to indicate if wires are plugged or not, or if basically the wire diameter was big enough so they are like barely see-through, so they had the precision was high enough, or this coating was thin enough that they like didn't close, and now we don't have the silk screen on top. Not silk screen. Was it solder mask on top? Hey Aaron, I watched your recent video. That current measurement unit was cool. I hope you had also a good vacation. I hope there's a pink status LED on the board. It's not a pink status LED, it's a power LED, and it basically says, let me show it. Can you spot it? It's here. It says pink. It's basically pink. Okay. So let me just take a few ICs and solder it quickly so we can test it. Okay. So here am I soldering. Okay. Oh, yeah, that's great. Okay. And I'm done. Oh, shoot. I forgot to switch the camera. Let's switch the camera here. Yeah, so, yeah. You, unfortunately, you weren't able to see how I soldered it right now, but this is the Flippy Flip. Here's the pink LED. Let's zoom in. Woo! So it rather looks like blown out like white. And I even put focus. Come on. What's happening? Bloop. Okay. I even used like a 1K resistor here to make it dimmer. And I had to put on a huge heatsink here. It isn't huge, but this is like this basic voltage, 5-volt voltage regulator. And it was okay without the ESP32, the temperature, from 24 volts to 5 volts. But you can imagine the ESP32, it draws like 500 milliamps. And that's quite a lot of power. So yeah, it needed a heatsink. So yeah, I also started like to already why the camera was not set up correctly here. I also started to update the sketch to work with the shift registers, since we have some changes to our former design. We used like the GPIO expander or PWM I2C modules, and now we have only shift registers. So we have a few shift registers here. These are like the low side sync, and these are the high side drivers. And here is a MOSFET that's for the reset of the current row or whatever row we set up. And the MOSFET, since it's 24 volts, since the MOSFET is 24 volts, we used like this GPIO board or like this driver board, and we need to get the gate to 24 volts, and we can do this with the 3.3 volts from here. I'm basically using an opto insulator in between, and the opto insulator basically activates the gate, and there is like a pull down resistor whenever the opto insulator is off. It basically disables the gate. Yeah. Hey Bruxus, the vacation was great. we did like we had a hike on the first day. When we were there, the weather was excellent, but then we are quite late. The plan was to go from. The plan was to hike on top of the mountain. That was like the height. The difference in altitude was 1,100 meters. So that's with untrained people in the group is quite challenging, and even it's challenging for me when I'm not trained, and I wasn't. But we started like really late at 12 o'clock or something. And when we arrived like at an altitude of so we had the difference of 800 height meters. That was, altitude was like 900, no, wait, 1,500. And we got like a whiteout there. So there was no point in going further to the peak, and we just went home. And all the week we did like smaller trips. We had one rainy day where we did some spa. And the last day, we thought we'd do like a peak. We go up the mountain again with the height difference was, or the altitude difference was also like 1,200. This was a different mountain. And we started early, like 8 early, yeah. My earliest was 4 o'clock in the morning because I couldn't sleep, so I went up the Mangard. But in the night it was cool. But we started at 8:30 in the morning, and we went up. What's the name of the mountain? Okay, I forgot the name. It was Kampenwand. So the peaks are like really like rugged. You need really to climb the peak. But yeah, we started from one side and we went up, and there was no like direct way to the peak, and we like wasted a lot of time, like 1.5 hours below the peak, like there's like a plateau. And then we went back and crossed the whole mountain, and then we met people who said, yeah, there is an ascent on the peak, to the peak. It's like half an hour, and we were already like totally wasted. It was like I don't know, we did already like over 1,000 meters, and we were wasted. But I couldn't like go home without the peak. And then we split the group, and I took 2 of the friends with me, and they are not experienced mountaineering, and it was really rough. It was like very steep, and usually you would need like equipment to secure yourself. There was like a steel rope that was mounted. I don't know how this Klettersteig, it's Klettersteig in German. And it was like really steep. You had to climb partially, and there was like a ledge that went like 500 meters like down, and I was really scared because I didn't know how the people would perform. And also we also needed to get down again, so climbing up is way easier than climbing down. But I managed to guide the people up, or they were like very, very cool with that. And then we easier going down. No, going down is like, if you have to climb down, it's like really bad. And then we started to climb down, and I was like always cheering them up and pumping them up. Yeah, you can do it. But when we got to the ledge where we have to climb down, my reaction was, oh God! that wasn't very motivating to the 2 people. But I went up front and climbed down, and whenever I had the chance to like get a good grip with my feet, I stayed there. and then just guided step by step, like really baby steps. Put your foot down, and because you couldn't see downwards, I said, yeah, move your foot to the left and lower, and there was like better step and so on. And it took a while, but we got down there, and we were really satisfied, and got like a cheesecake and beer on a hut there, and we were still at like 1,500 meters. And then there was the second peak, and we thought, oh yeah, that's the shortest path to go home. And we went another peak up, and then it was already like 5 p.m. and we were so wasted already. The legs hurt, everything hurt. And then we had another peak. There was nobody there because it was already late in the evening, and the sunset is about like 7 o'clock. And we had like 2 hours to descend 900 meters, I think. That really hurt. It was like a super nice hike if you had still the energy to enjoy it, but we were just descending, and we like made it without any injuries, but my knees started hurting. So we did like 2 peaks in that day, and then the one guy that was with us checked his watch with GPS tracking. He wasn't on the first peak, and he had already like 22 kilometers, and it was 1,500 height meters, so there was another 100 meters of altitude that we did for the first peak, and maybe a kilometer more. So it was like a really great tour, and we were like totally wasted. We were watching like something about politics because we had the elections this weekend, and everyone fell asleep immediately. So Scotland. Hey, Ian. Oh yeah, Scotland was great. I had a great hike in the Highlands, but this is already like 20 years ago. I was 3 weeks there, and it was one of my best hikes. Okay, but I'm distracted here. What's the fondue doing? Fondue, we need more temperature here, and we need some Kirschwasser. Oh, I have a rest of Kirschwasser here. That's needed, some schnapps. And then we need to like start testing the new board. Unfit. Fun memories. Yeah, sure. I love hiking and climbing mountains and so on. But I also realized that I'm getting older. It's like my knees are wasted. I was doing trampoline for sports in the last 10 years, like for maybe 5 years or something. And that wasn't good for the knees. It was a lot of fun, but yeah. Now I'm also untrained. I started jogging, but I think my knees need a little bit more training to get fit again. Fort William, yes! I started at Fort William and went up to Loch Monar. I think it was like 320 kilometers of hike in total. I ended like it was like a tour from Fort William up through the Highlands, not until like the top northern like part, but Loch Effric was super nice. Then I saw many lakes and hills, and I had also like rainy days where my crappy shoes back then were full of water, and the midges, oh, they are terrible. You don't go there in August without like a net around your head, because I had like, I counted one day, I counted like 300 like bites, midge bites. So like small bites, like red dots. If any one of you don't know what midges are, they're like that like mosquito like, you can say it's mosquito because they're like really tiny, like fruit flies, but they bite and that hurts. And I ended my tour in Scotland. I went because you have to end it there in Loch Ness, and then I hitchhiked back, and in Glasgow I went to, because I ran out completely out of food. I was super fit after the 3 weeks. I ran out of food, and what I had left was like rice and some chocolate paste in a, and I basically cooked the rice because my cooker broke like weeks ago. It broke like in the first days. I just took like 3 stones and like a can, cut half of a can, and put in methylated spirit in, turn it on, and just cooked with water from was it the creek water, and cooked the rice and put like the chocolate paste in and ate this. This was like my last meal in the Highlands. And then when I got back to Glasgow, I just went to McDonald's and I bought 8, it was 6 cheeseburgers and 2 hamburgers, and I ate them all. I couldn't move because my belly was so stuffed that I could, if I would stand up, it will burst and I will die there. Also fun memories. You are on the northeast coast. Oh yeah, that's a little bit. That's, I was like more on the west coast. Okay, so let's check out if we can make this thing work. Can I like use the camera, the additional camera here? Move it up like that. We have to like, we don't need to see my face. We need some code. Can we check the code here? Face gone. Okay. What was the main dish? Of course it's going to work. No, it's untested. I don't know if it will work. But I'm getting hungry with the that nice smell of this fondue. But the packaging was cool here. Like a gift packaging. Thank you very much, Andre, again, if you're watching, for the donation, fondue donation. We are covered for 2 weeks. I don't know if it's gonna work. Probably something is flipped there. I couldn't, I tested with the, I have the multimeter here, and I tested already, but I couldn't see any like signals going in and out. So let's check. I have rewritten some of the code here again. So let's check the schematics again. What basically everything changed there. Not everything, but the majority. Oops, this is not that. Where's KiCad just died or what? I had KiCad open. Basically, maybe it didn't like the change of resolution for my main screen. Magic smoke. No magic smoke so far. I tested it with 24 volts. The only magic smoke that we almost got is from the 5 volts regulator, but now I got a heatsink there. Look what I sent in the lab in the Discord guild. Discord. I don't know if I can show Discord. Let me. If I open Discord now, it will basically show all my private. It's showing my private messages. Okay. Let me check. Okay. Screen capture. So, release the magic smoke. T-shirt, 17 pounds. Okay, everyone who didn't find my Discord yet, it's this is the address. Oh no, it's not. Oh wait, sorry, it's not. There is something missing. This should work. Okay. Hello, Christopher. Oh, I'm getting hungry now. Story time was so long. Oh yeah, fondue is getting closer. Let's heat it up more. Who is writing? Okay, I close Discord again. Okay, so basically what we're trying to do now okay, Sniff, then get back soon because we need your help probably. What we changed is that we are not using like we were only using this type of shift registers for the low side. So this is the drain here. Okay, and now we switched from like a GPIO extender or GPIOs to, let me show it, to compatible 595 deserializers, I would say. So basically it's like shift registers and you get the outputs here and they do only like a signal. So there is no like current flowing here. And these are connected to the drivers, to the high side drivers. These are the high side drivers. And these have parallel inputs. So I can imagine there are like some ICs that integrate like the serial with the driving part, but I was too lazy to look for them. So I basically use twice as much ICs. And what else do we have? This is like the worst way to do power management, 24 volts to 5 volts. And the usage is like maybe 500 milliamps. So it's like dissipating this regulator is dissipating like what, 10 watts. This is crazy. There's no way you do this with without a heatsink. Or the ESP32 is like in idle state, like you need to put it in sleep for all the seconds, all the time. Okay, Dustin, we will do more on KiCad soon. You will teach me all this fancy stuff. I know the labels are wrong and so on. It's basically to see what we got here. Yeah, this is like, we have only like one reset. This is the drain for the rows. Yes, rows have only like one high side here. Where is the row? Here. We have 16 rows. These are the row high sides, and there is only like one. Is this even right? Yes, I think this is right. Yeah, and this is like the MOSFET. Oh yeah, that's my girlfriend. Okay, and this is this opto insulator, and I didn't put here anything, but this is, I put there like 1K. So this is also like maybe heating up a little bit. 24 volts, and there is like 1K here. Just for how long? What? Okay, so the main test is now, oops, to see, let's start with, this is the first serial in. This is the signal serial in here for the mobile phone users, serial in, and this is the ESP32, and now we want to check if we get, let's say, column 0, C0, this signal to drain. So we can measure between C0 and 24 volts or 5 volts, whatever you like, if this drains or not. So there should be like some voltage, or yeah, we can measure the voltage maybe. Okay, we don't have like a pull down here, but we can test this. I should have rewatched the last stream. Yeah, the last stream was like, we started with like a simple part, and the rest of this whole circuit I did like in one day. And Fruchtzweck, this is based on your recommendation that I can use this year for, what was it, your recommendation? I don't know. Or was it Sienna's? I think one of you two recommended that I basically use these shift registers to replace the GPIO expansion parts and drive the high side thingies. I think we weren't like done with this, and the last stream was repairing stuff, so I don't think we had, yeah, we had this. Oh, I also here's like, this is like 10 microfarads. Okay, I only found like 1 microfarad caps that I could put there. So yeah, because we have like this restrict here 24 volts. That's a common mistake you can put their like basic ceramic caps that will blow up because they are rated 6 volts. I better say no until it works. But it was me, okay. Yeah, at least it didn't blow up. We didn't release any magic smoke so far. I need to turn on the power supply. Let's not forget about that. And then I need to turn on C0 on and off, and we will see if we can get anything there without anything else connected. So it should at least change something on the multimeter. Why doing so? Okay, so I'm hungry. What's happening here? Is my fondue doing? Oh yeah, fondue is doing fine. Let's test the sunny fondue. Oh, I would say it's dry aged. No, it's perfect. Continuity tester, really? Does it work like that? Okay, so let's check my code. This is the loop. We have two different, oh yeah, one thing, oops, sorry. One thing. I didn't know, because this is like half bridge or like H-bridge stuff. If we need like different output enables for the rows and columns. So I have output enable 1, and for the drain of the, we have output enable 0. So this is like a slight difference here. We can control like the high side and low side outputs. We can control those separately, but now that I think about it, we don't have any pull down registers or anything. No, it shouldn't be pull down. It's like, no, it's okay. Okay, so the output is like, what do you call it? High Z. Okay. So enable, I hope this is properly specified here, 5 and 7. Oh, I should check if I did the right pins here. Serial is GPI 2, that's why it's blinking. Serial clock is 4, that's still the same. Enable 5, 17 and 5. Clock is 16. Oops. Oh, I hate this. Can somebody like, is this open source? Can I push like a proper zoom on mouse wheel in this project? This one is terrible. Yeah, clock is 16. That's all right. And we have reset pin is 18. Reset is 18. That's correct. Okay. Yeah, different. Hey, Sion. A different always, I think, because usually if we would turn on everything at once, there's like a slight delay that might cause like shorts, and but I'm not sure yet if it's really needed. We have coils in between, but no, not in between high and low of the column, I think. Okay, so on LEDs it might cause also ghosting, but not flip dots, I guess. Yeah. Yeah, that's just completely different matter with the flip dots. That will be a mess. Okay. So I disable OE1 and OE0. Okay, I basically doing nothing with the reset right now. Then I push bits commit 595. I will show these functions and then enable again delay and do it in reverse. And this is how it's done. Commit does only the RCK, which is this here. That basically, I think this was the one that basically pushes the current shift buffer to the actual output setting and the enable output set. So this is basically like if you okay, see you later, Hannes. So this is the commit and we have some delays here. So this is basically done like for a short amount of time. And then we have push. This is like the basic bit that is pushed, and as I don't know who it was last time that we worked on that, notice that we have to push them in reverse. So last bit first, and if we take a look at this, complete series, okay, we don't need to see that right now. And this complete series, we have quite a lot of bits. That doesn't fit anymore in like a 32-bit integer. But we have 32 bits, which are, the first 32 bits are columns, 25 columns, and then we have H0 to H6, which are basically extension. I have screw terminals. There's like a half bridge extension here that are not used in this circuit. You can use it to drive a motor or whatever you want to drive there, or a solenoid or whatever you like. But we have 32 bits for the low side of the columns. Then the next ones are on the rows. These are the high side of the rows, 16. And then we have the high side of the columns, 32 again. So we have 32, 16 and 32. So 32, 16, 32. This is like the order. And the last ones are high side of the columns. So let's check. Let's check again. Oh, simple. It's you, it's not Sion. Oh, sorry about that. I watched your video. Recent. It was about, what was it about? A few days ago, I shot one. Hello, Mainz. It was about 3D printing battery cases, yes. So, push bits. The first ones, column low, row high, column high. This is the order. Was stellst du an? So, I'm testing the new driver board for the flip dot display. So what's happening here is I am expecting just in the parameters like a bit mask and pushing the bits. I hope this is right because I just hacked it today. Pushing the bits from the back to front for the high first, then the row high, then the column low, and that should be it. So I'm basically pushing, this is column low and the row high. And this is, so we can measure for the first column C0 if we get continuity that's changing every second. That we can test. So let's upload this. I'm not using a power blogger. Basically my long USB cable is the fuse. It will dissipate any voltage difference of the 5 volts from the board to the PC by dissipating it in heat. Okay. So certainly, let me show it big. Oh, I'm so hungry. Why? Why am I so hungry? The fondue is great. I need more fondue. Where's my fork? Ah, here. My fondue fork. Oh, it's too hot. So let's put my tester in continuity. Okay, so one indication that the ESP32 is doing something is the LED. The LED is on, I think it's on the data pin of the shift register. And the last bit that we push before we sleep is either high or low. So that's by coincidence, it's blinking. And now we should see, I need to check how I populated these. Now we should see somewhere here This should be like one of the first outputs, a difference, but I need to turn on. Oh, I don't even need, for this check, I don't even need to turn on the power because these are driven from 5 volts and I think this is coming from USB now. Let me check this shortly, how I populated the board here. Okay, this is my crazy board. There are almost no wires, only like here, like only a few. Everything else is routed like perfectly, hopefully perfectly. Let me check, where is output? OE, wait, what? This is enable. No. C. Oh, here is C0. This is C0. So looking at the board, we have this pin that should blink basically. Let's check that. Okay, continuity, and this should be drain, and we have 5 volts here. Nothing. Okay, let's put it in volts. Maybe it was the wrong way around, but I only see like 1 volts. Showing only 1 volts. I don't know what's happening here. Oh wait, let me check something. If we leave the code, because on the flip dot we don't, wait, true enable. No, it's enabled push bits. Yeah. I could measure between the row and the column. I checked on the connector before and it wasn't working. Okay, I could use the connector. Wait. Hot. Burnt my hand with cheese. And the fail counter doesn't work. It's sitting here without power. Yeah, but the continuity tester, I don't know if it shows anything. Okay, let me check. No, not this one. C0 is here. Yeah. C0. and this is ground. Oh no, this is reset. Oh, okay. I need to use proper ground here. Welcome back, Hannes. Ah, more cheese. I didn't have lunch yet. Okay. So how do I measure it? If I measure between 5 volts and C0, we should measure voltage, shouldn't we? What is this? 1.5 volts. What is this? Is it even working here? I should maybe remove every IC except for the first one and then test it again. Or should we measure row 0, which is basically here? This is the high side driver. If that works, then everything before that will work too. No, it's also showing 1.5 volts. What is this? Okay, let me check again if we can see anything in the code. Is there 5 volt on the ICs? Oh, good question. No, it's not. It's 24. No, wait. There should be 5 volts. Okay, let's check again. Let's zoom out a little bit. Where is the 5 volts input here? This is 5 volt input. Okay. Let's measure. Yeah, we got 5 volts here. This is 5 volts. Then we need to check if the enable is active. Where is the enable? Output enable is there. Oh, yeah. Enable is not enabled. Okay, wait a second. So I get only like super short signal here. So the problem is in the code. Zero, true. Let's check. Okay, I just problem finding, yeah, debugging. Let's do it like that. Let's enable it. See if we get fault finding. Oops. Oh, active low, yeah. Okay. But this is what they do, I think. Wait. Yeah, this is what they do. They invert. So by doing true, oh yeah, it should be 0. Yeah, no, that's okay. But then why don't we get an output? Okay, wait a second. We might need the voltage. No. 5 volts. No, this is the ground. It's always the ground. Ground. Many grounds. Solution finding time. Or we want too much. Let's try just pushing 1 bit. And see if that works. It's grounded. Oh, this is tasty. Ah. I only had like 1 kilogram of fondue last week. Not yet. No botch wires yet. I still hope it's a software issue. Oh, camera died. Battery low. My oops. My battery is basically no, my adapter for the power of this camera is done. Yeah. Where are the other batteries? Yeah, here we go. When doubt, blame software, yeah. We can basically push a bit. Okay. Push 595 0 commit it will basically alternate. Okay. way easier. Now we have only the chance there is a bug in the commit. I would really love to just test it on the flip dot, but I'm scared. I have only one. If that breaks, I can't do. I can't make a video on that. Oh. Oops. Oh. Oops. Oh no. I have cheese in my compartment here. I need to let it cool down. It's flux when I solder these parts. Some extra cheese flux. Fuck. Sorry. Cheese everywhere. Yeah. Cheese resistant. Whoa! Oh no. You can see what I'm missing here. Okay. Yeah, let's test. So let's measure voltage. We should measure between 5 volts, basically this pin. Nope. Okay, what was this? This is enable. Oh, it's disabled. What? What? Why? What? 4.5. Why is it disabled? Five on 5? No, it doesn't measure 5 if there is, it's the drain. I measured the drain. So the column C0, but I measured 5 volts, so disable on, it should be enabled. Wait, what? Yeah, this is inverted all the time. On, off, true, 0, digital write. What? What's the init? Output. And, oh yeah, this is digital write. 0. This is the pin. Hello ID. Wow. What? ID. How did you manage to get like such a short name? Oh no, you can set it basically. Do you have a channel? So what we are doing currently, we are looking for the box. Pin, enable, if it's on true, should be 0, digital write 0, and the last thing that we do, OE1 and 0, there are people with only a dot or a hidden symbol as their name. No idea how they do it. Hackers. Can you use the Unicode characters that rotate the text by 90 degrees or something? Or shift it somehow? Reset pins are good question. What reset pin? Ah, you mean that here? Oh! Serial clear. What is serial clear? IO19. Oh. Let's check that. Ha! I don't even have it here. So we should set it to 0, I think. So init, show init. This should be up there. And I call it like that because naming conventions. No, there is no inverter. We should set it to 0 then, because we don't want to clear. Is clear high or not? We don't want to clear, so we leave it low. It's pin 8. I can check on my initial circuit. Who knows? Might or might not be. Do we even have it here? Serial clear. This is okay. Let's test it with this might be an addition that I basically forgot about. I might have hard-coded it before, and now it's tied to a pin since we have 3 pins. But Christian, that was a good suggestion. We need a fade. Oh no! I need to update the code again because I didn't. We had problems with the live stream recognition before. Let me check if we get anything now. Oh, that's AC. Does it always smell like that? Okay, where was this? Let me check the signals here. This is 0. The storage register transfers the data to the output buffer when the shift register clear is high. When the shift register clear is low, it's cleared. Wait. I need the schematic. It's insufficient. Not the schematic, the data sheet. The storage register transferred data to the output buffer when shift register clear is high. Which pin is it? Clear, that's the 8th pin. I check on the old circuit. Yeah, this one is floating here. No, it's not, wait. Yeah, it's floating. It might have an internal pull-up. Okay. Last byte. Are we there yet? No, not yet. So we need it high. It might have an internal pull-up, that's why, so we need to say it. To set it to high. Like that. Let's check now. So first of all, I check if we get what we supposed to have here. This is yeah. Somehow it's turning on and off. Don't know why. Maybe is something heating up here? No. Why is this changing? No, serial monitor doesn't say anything. Okay. Oh, I think it works now. We have like between open and it measures, I don't know if you can see it. I think the shift registers are working now. Okay. Okay, I'm excited now. I'm excited. Okay, so something is happening there. So now let's do let's switch from this to this. We don't need the output anymore. Let's remove this. So we can see if we get like proper transfer here. So Christian, thank you for the suggestion. The best is just to connect every pin to a GPIO, so you can, you can do it in software later, either connecting to high or low or whatever you need. Okay, now we should have the high pin here. Can you see? Can I put something there so you can see the output here? Okay, 0 volts. We have ground, and this should be the high side pin. Yeah. So I don't know if you can see it, but the high side pin of the row is also doing something. So this is working. Now we need to, I'm happy and excited. Now we need to fix the transmission and do the right thing. Okay, let's try enabling and disabling everything. This is basically garbage here, but let's do it anyways. Did we need that? We don't need that here. Let's see if it's still working with that. It's working, yeah. It's doing something, it's working. It's an assumption. Anna suggested reset stuff. Anna deserves also an administrator or moderator. Here we go. Everyone is moderator on my channel. Almost. Okay, we have new code. Let's see if we still get a high signal there. And then we can try with 24 volts if it's still working. Okay, so ground and this pin. Yeah, it does something. It does something still. So now a stream where Fruchtzweck didn't suggest a fix. Confusing times, yes. So now we need to test if we got the reset. Not existing 24 volts, yes. But it's doing something. And it's doing... Fruchtzweck is confused as well. Should we try with 24 volts? Magic smoke? Okay. Let's turn on the power supply and you will see, you doubters. Okay, I turn up. Okay, the input is now, what is this sound? Something died. Something just died. I heard a high tone. Okay, the power supply is running at 6 volts. Now let's turn on 13 volts, just to be sure. Yeah, 13 volts also working. So here you go, you doubter. It's going to work, yeah. Okay, now we need to reset the pin. Okay, we have the reset pin. We didn't test the reset yet. We need to I learned something today. Whenever my multimeter just shows random values, everything works fine. Woohoo! Yeah. Okay. So let's make a plan. Let's make a plan. Okay. We have this. Is there the dot? Push bits. There's a no, this is clear. Show. Okay. Let's set dot and then X and Y. Yeah. That will basically set one dot. That's what we do. We want only to show one dot. Let's copy that. Push bits. Then we have X and Y. So Y is the high side. This is the high side. This is 1 shifted by Y, the row, and the column is 1 shifted by X. I think that's all. So this is the lows, the drain. Oops. And this is the source. And this is the source for reset. That commits, enables, and done. There is no delay or something. Okay, whatever. That sets the dots, and now we need to reset row. No, it's column. No, it's row. No, it's column. We reset the column. We could reset every column if we wanted to at the same time. I think the MOSFET can handle that. Oh wow, we could completely clear the complete flip dot, I think, at once. X, and what we need is to now we need that here. This is 0, 0. This is Y, and then we need the reset pin to set 1 for a short amount of time only. This is like change, where is it? Reset delay. Oh, the set should be also set only for like Looney is just uncommenting random lines, all right. Okay, we enable the outputs. But only for a short amount of time. So this is delay set, I think. Set delay or change delay, what? Because we don't want the current to flow all the time. We had this also before. Now we need to set everything. Oh, is it enough to just... No, we need to set it to 0. Everything 0, I think. So just like that. Commit and set it again. Oh yeah, okay. And here we also need to set this to 0 again. So I think we need to disable this again. Yeah, but disabling would be like floating, and we want it actively to disable the high sides. So the high sides need to be disabled here, I think. Otherwise it would be floating. And the charge could stay like high enough to be enabled. I want to be sure to pull it down. Flipping heck, he's flipped out. Okay. Now we can delete everything here. and test set dot 0 0 reset call 0. Yeah. Hey Ray. Yeah. So I'm happy that you agree. Okay, so this is the next test. Oh yeah. Ah, that's a hack. That's a hack. Ray, you need to like rewind, because I had story time for half an hour or something about my vacation, but too long didn't read. It was great. We had great weather and I did some hiking and we had quite some fun. Thanks for asking. And I came back to a full post post box of stuff. Oh, I got quite some neat stuff that I might want to share as well. Let me show some of that right now. Let me show some of that. Where is it? This here. Where is this? Do I have something else? Oh yeah. Okay, face cam. But up. So this is the temperature sensor for the fondue automatron. So we will expand like 1-day challenge, make a perfect fondue temperature. Then what I also ordered is, I can open this. Servo tester. I have no clue. Unfortunately, it doesn't have like USB power here. I need to connect some voltage here, but yeah, I have a project in mind with servos that I want to test with that. Then I also bought like analog monitors, like super cheap ones, because you know we are like notorious. We can generate. Look at this. Here's even some cable, some power cable. We can generate analog video signal, and oh, this can be even taken off. Here are some controls, and I think we can use that with an ESP32 for, I don't know, making props or something. Like, I think that could be cool. So this one here, I don't know how much this was. I think it was like $10 or something. They are really cheap. As far as I know, the drones are using like the FPV drones are also using analog signal. That might also work with that monitors. And this is the second one that I wanted to test. Another El Cheapo version. So I just took some to see. Oh yeah. Okay, that looks like a iMac. Oh, okay. So this is like not very neutral, but we could disassemble that and basically take out the screen if we want to. Fondue cam monitor. Yeah. So I got these here. What else did I get? I might or might not have gotten more things. Yeah, but this was also filling like my what I was wondering. These three things came in one packet that was probably packet like it was one big bag with 3 bags inside. So I think what AliExpress does now is to regulate with this import stuff in the EU. It's shipping everything to Netherlands. Then they are just packing this up and doing the last mile shipping with, I think it was Hermes. So somehow they figured it out how to avoid extra charges. Oh, I also got like a small scale. Here, this one. But it looks better than it feels. It feels like really cheap. Like this is like cheap plastic. This is metal. And the resolution, no battery. The resolution is like 0.01 gram or something. I don't know if it's hackable. AliExpress, they combine shipments in Belgium. Okay. Needs a bubble sensor in case fondue overheats. Large import centers. Yeah, I think since we got this is crazy. Whenever I was asked if I'm worried about these import regulations that EU is coming up with these like $20 extra for small packets or anything, if I was worried about that, and I never thought about that because I thought, okay, they will figure it out somehow. And now that we got these regulations, the sellers on AliExpress are forced to use AliExpress shipping, and that basically improved so much that I get my packets like within 2 weeks now, every single packet, without any problems, without any customs. So everything is covered, and it's basically, it improved. So against any like expectations or worries that everyone had before, the situation with the small packets improved, and all the lobby that wanted those extra charges to maybe like improve like the markets in Europe basically failed at this point. Hello, Max. So we were testing. I'm rambling, and I like the new system too. The before might be slightly cheaper, but now I order up to. Yeah, and they charge AliExpress charges the customs somehow, or VAT or whatever. It works way better. I didn't have like a single shipping that took like a month like before. Everything shipped within 2 weeks. Okay, let's continue. Pew. We wanted to see what happens there. We were flipping a dot. I think we uploaded this new sketch already. They exploited the new system, yeah. Or they basically consolidated every single shipping method that was there, improved it, and maybe they're using even trains now, not like the shipping containers or air shipping. So because we have like this Silk Road, this new Silk Road. Okay, we need some power here. Okay, and I will measure what we got. What we got here. Let me check. Ground. Yeah, there might be something, there might be not something here. Something is happening randomly. Okay, great. So let's connect the flip dot, shall we? To have it on camera. Oops. You want to see it blowing up? Oops, no, screen capture. I never tried to connect the new one to this, to the display. I don't even know if it connects. Let's turn off the power for now. Let's disconnect this here. Does it even first fitting here? Oh, that's too close. Let me get the camera. And I need to record as well. Okay, let's connect it. If it blows up, then I have it on camera at least. Ah, this improvised connector. Okay, I think this is so there's plenty of space, but I put in some mounting holes and they are big enough for standoffs, so I will use some nylon standoffs later. And now let's see if we get anything or just magic smoke. Okay. This is like too dark. Let me change the ISO to 800 at this point. Okay. Uh-oh. Nothing happening here. Let's increase the voltage. Nothing happening. the microcontroller is blinking, so the code is running, but it's not doing anything. Okay, let's turn off the power. Oh, we didn't test if the MOSFET is resetting at all. Max, I had a wonderful vacation indeed. I thought the purpose of this bot was just a pink LED, isn't it enough? Yeah, not yet. Looking from this perspective, the matrix looks big. Okay. Let's try. Let's check the code. Let's check the code. If we can basically set the first dot here. We want just to set the dot. Oh, that's the reset delay. We need a set delay. Yeah, but anyways, let's do like 100 milliseconds and disable again. You already satisfied? Hi, Brian. We are just about to release the magic smoke. Oh, I need to reconnect it again. I don't want to break it though. How do I? Can I somehow fix it in place so it doesn't break? Okay. Like that. There is a supporter pre-sale? Now if you want, cool. I need more cheese. Take my money. Come on. Set dot. So we get rain, we get high, we commit, we enable, we delay, deactivate, commit, enable. That should work. Or die. Okay, we see a short blink. Okay, we get but nothing is flipping. We had some current. We had some current action, but nothing was flipping. What was this flipping sound? The flipping sound was my power supply. I can show it here. When I turn it on, it was current limiting. It was switching basically. Oh, I was recording all the time. It ran into current limit. Yeah, but I don't want to. 400 milliamps for one coil should be enough, don't you think? Or should I use more? But then I feel it will like explode or something. There is a delay here, that's 1000. Try to power the coil directly. Maybe let's use a little bit less current. Okay. I don't want the board to melt. Maybe let's check again if I do it right. So, what we do here, is to set, no, this is reset call, here, set dot, we can maybe shorten this a little bit so it doesn't heat up much. Set column to low, set row to high, and column to low. Where's the, or deactivate column high. Then this should be like, I'll update it. Should we crank up the current limit to more than 400 milliamps? Jay, I don't know. Crank up. Yeah, but then it will melt. You would not? Something's off. No dot flipping here. Okay, let me turn it on. No, I cranked it up to 1 amp and didn't get anything. Okay. Let me check the voltage here. Yeah, there's no way I can measure this with this multimeter. Let me get a scope. Scope, yeah. There's only not much space here, but I'll get a scope. Ah. Maybe I should just clean this up here, this mess. Yeah, I don't think it needs that much current. I think there's rather a short of some sort. Maybe this MOSFET is like connected wrong or something. Oh, we can do another test. We can do another test. There should be no current flowing if we basically activate the high side and not the low side. So if the MOSFET is active, I will change the maximum current again to 500 milliamps. So if we set the dot like that and we don't do this, then there should be no current flow because we have the row high, but the drain is off. So this might work. Is the schematic available somewhere? J. I don't know how to... I hope you can screenshot this and read the details. H bridges everywhere. That's what it is. Okay. Did I upload? Yes, I uploaded. Okay, let's turn it on. Now we should have no current flow. Yeah, there is current flowing. Okay, so we don't even need the scope. We have the current flowing through the MOSFET here. There's no other way. Let me check that. Oops. So this is the problem. Reset high. Otherwise, so what we do now is we have R0 activated, R0, but we have also here's R0, and the only way R0 is connected to ground is over the MOSFET here. So reset. I don't know if this is inverting or what. I could measure that one here. Why is the opto required? Because this is 24 volts. We need the gate to be 24 volts, and this is 3.3 volt logic here. Yeah, but it's uploaded because it's saved already. Okay, let me try again. So this is the easiest way. Yes, we need the FET gate to be like the same level here, 24 volts. This is how I understood at least what I saw online, and how the board that I used before for the breadboard version is designed like. It could be that I used the wrong MOSFET though, or a different pin out or whatever. Is this even... No, this is right, yeah. Yeah, that's basically, that's why we need a FET MOSFET here, because we don't have like a full H bridge. For resetting the row, we can only use, like, we have only for all the rows only one drain here. We have an individual drain for each column here, but not for the row. So when we change the direction of row, we can do only like column wise. I have 1K here, 1K here, everywhere 1K. The opto LED resistor, they recommend like, I think it was 3K. I'm using 1K. The pull down seems to be R. Yeah, 1K. I basically used 1K here, and the pink LED also 1K. So I don't need like different resistor values. That's like middle ground. No. J, what? Yeah, I need to set this. How do I set the values? So I need a different MOSFET or what? Which one did I get here? No, this is not a MOSFET. Is this a resistance pirate? I might need a different MOSFET then. V properties E value no 1000 R E like that. I also found a different bug in my design. Ah, come on. Did we try to use spare 7 open drains in parallel as reset drivers? Yeah, we could use that, or we use them as extra H bridges, but yeah, but that would require bodges. Let's just switch the MOSFET for a better one. So where are my MOSFETs? Is it really? Active low. What? Ash, what are you talking about? Active low what? We fixed everything that has to do with the outputs. What we are trying to achieve now is to make the okay, you know what? We can change the voltage. Where's my FET? I need the MOSFETs and I need the specs on the MOSFETs. I thought they are like 30 volts. Really 16? Are you sure? The higher the voltage, the faster it gets turned off and on. That's why I used only 1K resistor as a pull down, so we get some fast action there. Or slow charging if it's too high. Where are the FETs? This is not a MOSFET. Where is the MOSFETs here? I hope I used the right one here. Ah, here. Okay. Let's see. Yeah, 55 volts. That's no, this is not the one. I'm still looking for the FETs that I have used. There's so much stuff on my table that I can't find. Is it even a MOSFET or? Okay, what did I solder there? I might or might not have found the error. Fruchtzwerg. Spot the error. The upper one is the MOSFET in quotes. Fail. It's not a LDO. Okay, I will just disconnect it. I basically had two tubes of this package, and I thought that the one was the MOSFET, but it wasn't. It was basically... Okay, I need to desolder that and fix that issue. Ah, silly. But where are the MOSFETs? I thought I got those. There should be like a packet with MOSFETs that also arrived. I had two tubes. And I thought one of those were the FETs. Where are the tubes? No, I lost those as well. What? Look at that. I thought, oh yeah, that must, this is the, both are the regulators. Ah, yeah, there goes the battery. I don't have a battery left. Shoot. Yeah, my power supply died. Wait. That won't last long. I need to check if I can find... another battery, sorry. No, that won't turn on. Okay, both batteries dead. I have more. Patience. Where is my photo back? Okay, it's not here. And then let's take this one here for now. Okay. There should be somewhere one more battery. Okay, so what I wanted to show, both tubes are 5-volt regulators, no, not MOSFETs. So where is my drawer with the MOSFETs? And I thought I received a packet with MOSFETs. I try to find, this is not it. Somewhere here around in the lab are my N-channel MOSFETs. I know I received them. Okay, this isn't it. This is the regulator. Oh, wait. The drawer is right. It's the wrong. Okay. I think I have some here. I found the NMOS drawer. I need just the right package and the right. So what do I have here? Okay, let me check. Let me check what kind of MOSFETs I found here. This is what I found. Is this L version? No. Regular version. 60 volts. Now I need to check if we have tab. What does it mean, tab? It's stupid. 1, 2, 3, gate. 3 on and 2 is D or what? $60 amp. The MOSFET should be right if we get the right legs here. So we need, this is, okay, let's compare. This is the right configuration, otherwise it might not work. We might need to change it because I can't find the MOSFETs that I bought. They're probably somewhere upstairs. Okay, so we have gate S1, that's right, tab 2. Yeah, the configuration is the same, so we can basically replace that one. What does V voltage gate source voltage, wait, gate source voltage plus minus 20. What does it mean? Still a bit low. What do you mean, Lars? Is this page 3? Yes. Oh, so we are too high or what? Oh, okay. Shall we try anyway? Or do we put like a small resistor in between? No, we don't connect like. Can you botch that with K resistor on pin 4 of the opto? You mean here? I could do it, but can't we just put a resistor? No. Okay, yeah, we need a resistor here. Give the opto 5 volts. You mean here? Yeah, but the gate will not be high enough. Why the gate of 5 volts won't be high enough? I'm worried that we don't get the. It needs a 555. Only needs to be 10 volts max. My experience is that we get like some resistance there. Oh, that we get like some resistance there if it's not high enough. That's why I like to drive the voltage always high. Okay, I give you you know what we do? We just don't use 24 volts, we just use 20 volts, and that's all what we do. Or 19 volts input. for now. So I don't need to budget. I just need to replace the MOSFET. I have also different MOSFETs that I salvaged somewhere else. I can check if I have a different one that is more suitable for that. Okay, the experts are shouting at me. Why are you shouting at me? Expert. Okay, I have different ones in my drawer here. Different ones that I salvaged. P5 NB 40 FP. I used to like, oh god, what is that? That's like super old school. What is that? 400 volts? What? 30 volts. That one should work. Look at that. Or am I wrong? I need a proper data sheet. This one has a terrible RDS. Oh yeah, in resistance, yeah, because it's made for high voltage. Okay, let's check another one. I have more salvaged parts here. That one looks like really cheap. P3N B60. A whole tray. What's that? Show it to me. 600 volts. This is getting better and better. Plus minus 600 volts. What's the resistance? 3.3 ohms. Okay, yeah. Okay. Okay, dudes, we just try one of the ones with the. Oh, I have yet another one. Okay, wait. We have. This is like, which one is this? 6FP. Wait. 6. Oh, yeah. I found one which is better. I have this one as well with the L option. Oh no. This is even worse. Okay, let's take the other one. No botch wires. It's perfect. It's perfect. We might add like we might add like a resistor here. Here, we can put a resistor in line here. That should be easy. Put a resistor here. We don't even just remove even the... Yeah, we will try, oh wait. They are perfect. My boards are always perfect the first time. Okay. Now we need to use the sucker to suck out everything. That's one of the occasions where I need this thing here. One of the few occasions, though. But I'm wondering where the heck are my MOSFETs that I ordered. This thing is so shitty. What is this? Oh yeah, that's that compartment is probably full of, oh yeah, it's full of solder. Yikes. Okay. Oh yeah, now it's better. No. No. I think I need to add some solder here. Some leaded solder. Yeah, that doesn't work. No. I need to remove everything here. Ouch! Oh, this is hot. Let me get off this heat sink. It's too thick. I can't get rid of that solder. Piece of junk, really. Okay. Let's turn that off and use that one here. Helping hands. Oh, this is not very helping, but okay. I just want to help you to see what's happening here. Oh, I might want to suck it out later. So I get this. It's hard to heat this up when this thing is designed to dissipate heat quickly. I need more heat. I hope I don't burn the board. You know what? Different strategy. You probably suggested that already in the chat. Just cut it off and then remove. Okay, I need wick. Okay, crab, and wick. My solder wick. It's so awkward to do it like this, but otherwise you won't see anything on camera. Okay, one is open. Still. Yeah, probably the gate is done because it's only a signal, but the other ones are like thick traces, ground traces, and come on. Oh yeah, I will add some leaded solder. That will help the flow. Okay, leaded solder trick. Nope, not yet. It looks like it's already full. It won't reflow. Okay. I changed my strategy again. I will just push it in while trying to heat it up here. Like that. Okay. And try not to burn myself again. More, 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 a little bit more. Okay. You probably all already fell asleep. So let's hope that's the last time that I need to change this thing here. Oh! Day counter since last accident changed again to 0. I don't like these things to fly around, the legs to fly around my lab, because they tend to cause shortages. Shorts, not shortages. Okay. Let's be done here. Okay. Oh, that's hot. Still hot. Still hot. The MOSFET has like a good heat sink. Okay, what I think I will do, I will remove this pad here. That's for insulation, but I think I don't need it. It's better to have like proper connection here. And yeah, I hope I don't get shorts. What do you think? I will use some Kapton tape. Okay, now I read the chat. Yeah, I don't short the regulator. I will use Kapton there. I will use Kapton tape. Let me just think about, I think this way around. So I will just put on Kapton tape here like that. That looks, it's looking shitty. For those who don't know what Kapton tape is, I think it can resist heat up to 400 degrees, something like that, 400 degrees C. So it's a good insulator here. No, I don't want to bend it like that. I think, how do I bend it? So if I want to, okay, I will leave it like that. That's also stupid with this. The standoff is like, okay, this will be better for now. Okay, I can change it anytime. Oh wait, this is our Kapton. Oh no, it's not close enough. Oh damn. That's a fail. Okay, let me try again. I'll use this piece like that. Okay. that good enough? I hope so. Otherwise there will be magic smoke. Oh no, now it's between the regulator. It was too close. Fuck me. Sorry. It's either too close or too far away. How about now? Okay, now it's good. Okay. Okay, soldering this resistor in between will be challenge. This isn't holding. No. This is bullshit. Let me remove that. Okay, last try. Okay. Should we turn it on? What do you think? I set the voltage to 19 volts. I have no clue if it's doing anything. Let me turn on again. It doesn't draw much current though. Okay. Let's connect the matrix. It doesn't. Optos can be tricky. Okay. Okay. Moment of truth. Let's see if it releases the magic smoke. Oh. Ah! Oh, wait! The dot is flipped. Okay, okay. Dot is flipped. Is this by chance or what's happening here? Let me turn on again. Oh, that's... Okay. Let's turn on again and see if the first dot flips. Nope. No, we have current limitation here, I think. No. Huh? My touch sensitive light is also turning off. We have some... Is it sensitive to my circuit? No. Okay. I will release that and turn on again. Okay, so we get at least the lamp works. You are mean. No, it doesn't. It turns off by itself. Huh? Okay. What should I do? Let me clean that up here. Is there any solder in between? What we making a wireless lamp button, lol. Flip.control. Same MOSFET. Stick the meter. Yeah, I know exactly what's happening here. Or at least I think I know. So Ash, let me explain that. So this is the reset high. It's basically reversing the rows. This is the only drain for all the rows. You have the rows here. These are only controlled by these high side drivers here. But this will only put current in one direction, from row to column. But to reset everything, you need to have current from column to row. And this is going then over reset high here. Yes. That's why it needs to be a little bit bigger. We might have used like it was possible to use like the spare 7 bits that we have on the low side here and not using like this MOSFET at all, but it's too late now. Mock schematic for the Flippy board. I can do one. Oh no, that's paint.net. We need MS Paint. Okay, schematic was coil, and then we have like here is column, here is, let's say this is C0, C1, it's like this pubic coil here, and then we have there are some diodes in between, so it doesn't R0 and then we have oops, let's say like that. R1 and then we have what is this, RSTH. Like that. So what happens now is we can put here, we can put different color, high, low, high, low. Here we can put only high, and here we can put only low. So when we put here high, then the positive current can only flow to reset low. This is resetting basically a complete column. Column 1 would be reset if you have this high and reset is low. If you have this high, then you can pick each individual pixel here. This is what we got. Okay, now what's happening now is that we got a short here. So this is always like, seems always to be open. We need to set row 0 high and to high and column 0 to low to set the flip dot in the corner, not involving fed at all. Yes, that's what I try to do right now. So the fed seems to not work properly because I do only set dot, and what set dot does, it enables the outputs, it sets, oh wait, this is even off. It shouldn't do anything. So currently for the test, we are only setting the row, which is 0, to high. So it's sourcing, R0 is high. Then we delay for 50 milliseconds and then we deactivate it. So even the drain is deactivated. So it means that I need to check what the MOSFET does. Have I missed much? Yes, you have. Okay. Let's test what we got at the MOSFET. Yeah, the ESP is probably resetting because I see also the LED resetting. And it's going to like 1 volts. It's 100% resetting. We got like a short. We got a short with the MOSFET because I will check it. I will connect. We only need like a male jumper. We need only a male jumper between. Okay, so now it's active. And you see the LED here. This is row 0. And this is the reset. And this should basically short it. Yeah. That's what's happening. Yeah. That's what's happening. So we got something on the MOSFET that's not working properly here. Okay, let me check. Let me check what we can measure there. The MOSFET should be off. I can. Okay, I will use that. Here's the ground. Which one is 0, 0, 0, 18, 19 volts. Okay. Zero. Zero. Something's wrong here. Okay, let me check that. $16 volts, yeah, but that's at 20 volts. And it's exceeding voltage. Yeah, but Jay, we didn't exceed it. We have 19 volts for yeah, I will test the continuity here. Do you think the MOSFET is fried or what? Yeah. Okay, I turned that off. No. No, we lost the camera. Ah. Okay. We don't have any cameras left. I went through all the batteries. I can maybe use another power supply. Let me check that. Okay. Okay, I have found another power supply. that will work. Source to ground, drain to 19 volts, gate to opto. Yeah, Johnny, the problem is that my other power supply died yesterday. So I didn't have even chance to reorder it. But I have a second power supply that I just found. Last. Okay, so back to the drawing board. What's happening here? I have continuity. I have continuity. Continuity with ground. Even though everything is turned off. This should be pulled to ground. Or is it dead already? Or is it wrong way around? It might be flipped. Fat is toast. Polarity looks okay. I checked for solder bridges, but no, doesn't look like that. Let me test a little bit. And then check again. And then test a little bit and then check again. Okay, so is there continuity? Okay, this is gate. How did I toast it in a microsecond? It can't be. What? Should I use it only with 12 volts now or what? Come on. Okay, I checked the data sheet again because I'm confused now. No, it's 16 volt. And we used no 20 volts. I used specifically I'm using, where is it? This is not the one. I'm using, this is not the one. I'm using this one. $20. And I'm running it at 19 volts. One, this is gate, it's correct. Okay, it says D is tab, not 2. Maybe that's the problem. And source is on both 2 and 3. But that would be like really awkward. It shouldn't, because there's like a plastic version, completely plastic version here. Yeah, that one here. So it really shouldn't. Ah, is it broken? Normal VGS 10 volts. Ah. It's not absolute max. Absolute max is 20. And we used 19. 4 volts. Okay, you know what? We budget. You win, I lose, we budget, and then we try again. Ah, you people are killing me. 3.3 k ohms. Okay, let's fix that again. No, it's not. Currently it should be off, but it's just stick a 10 volt Zener between G and S. Oh. Fondue is cold because I'm full already. Okay. Friends, let's cut off the MOSFET again. MOSFET done. Okay. Here. MOSFET gone here. Are you happy? Are you happy? Okay, MOSFET gone. The voltage regulator is kind of loose. Okay, voltage regulator happy now. Let's turn it on. Okay, circuit working. Now let's flip the dot on. No MOSFET action, just flipping the dot. Want to see this dot flipped. Nothing. What? Why not Flippy Flip? Ah! What's wrong with Flippy Flip? Is it working? Nobody knows. I need some standoffs here, otherwise I will create shorts. I think the microcontroller doesn't do anything at the moment because I don't see any current flow. Let's check if the microcontroller even lives. Maybe we killed everything here. Microcontroller, or at least flash, is still working. Okay, I need a standoff. Some nylon standoffs. Let me plug that in first. Yeah, good enough. I could use bigger ones. I have bigger ones. Here. Ah, come on. Okay. Okay, nylon standoffs are okay. All the screws are magnetized here by the Flippy Flips. Hey, it should flip something, but I don't see anything happening. Maybe I should set the voltage higher to 24. Oh yeah, we disabled the drain. Ah! Okay, let's enable the drain again. Oops. Oopsies. I have this times 0 here. It should be fixed in a second. And then we should see some Flippy Flip action. Woo! Okay. No. Okay. Okay, are you ready? Oh, what's that? Are you ready? Let's turn it on. Yes! 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 Yes. Okay, now we need the reset now. We need the resets to work. Okay. So we fixed the circuit. Okay. Whew. It's getting tight. Yeah. We have a winner, okay. Winner, chicken dinner. How did we kill? Well, how did we kill the MOSFET? Do you think we should? What was the fix? Ash. We removed the MOSFET. That's all, and then I activated the drain again. I don't think we need the oscilloscope today. I will remove it to have more space so we can work on that. Okay. And I will remove the remains of the MOSFET again, and then we will add do I really need to? Okay. Where is the 5 volts? I have 5 volts somewhere here. Yes, we can do this. We can use 5 volts. Okay, let me remove that. We will use for the gate, we will use the 5 volts. We can just get from the pink LEDs voltage source. Let me remove that crap. We can make it 5 volts, as you said. Okay. This will be quicker this time. Wick. John Wick. Unfortunately, everything is on the bottom, so I think, I mean on the top of the board. Let's try the cheaper version here. Oh, the pad is already coming off. No good. I can't get that one out. Guess I have to live with that one. Ah. Come on. Okay. I think that one is in. Now I need to fix that here. This is the supply. Let me check the... that's an easy fix. Oh man, is this easy? Okay. Okay. There's my X-Acto knife. This will be such a tiny botch that nobody will ever see it. Okay, this was the 24 volts line. No continuity. And now we just need to connect this . This trace to here. This is 5 volts. I love it. This is the best. If you design a PCB yourself, you can simply fix that so quickly. Find like the optimal way to do so. I need to be careful that I don't set the 5 volts to 24 volts. I want basically to cut everything off here. Gone. This is a Q-tip. Huge, isn't it? Okay. I know it's not in focus, but the standoffs are on. So, okay, let's switch the tip on the soldering iron, the smaller one, and I don't know how to get there. To wait for the soldering iron. Ah, crap. Okay, this might work. Ah, can't reach it like that. Okay, what I can try is to heat up something else, like the remains of our MOSFET, former MOSFET here. That's too huge. All right, let's take the resistor. Maybe we can make that stick somehow. Okay. A little bit more focus. It's so high now, I can't reach it with my eyes. How do I get there? That was a terrible idea. Who of you had this idea to solder it there. Ah! Okay. The fuck? Okay. I got a little bit more space now. Did I get more space? Yeah, a little bit. Ah! Stuck underneath the microscope. I think I will remove the cap now. What's I did something wrong with the ground planes, that all the pads are completely connected. They're not like, this is getting hot again. There are not like this heat thingies. I need to go higher with the temperature, I think. It's so hard to desolder this. Okay, got the cap off. Okay, now I can put in the cute borch. I hope you people are enjoying yourselves. Why is this moving. Looks like not a good Bond. James Bond. Uh-oh. Uh-oh. Ah. This is getting embarrassing. Everything is uncomfortable here. I have no space to solder that stuff. I can't see through my microscope because it's too high. What is this solder here? What is this blob? Even my multimeter is getting impatient. Okay. Flux. Ah, like that. Where is this going? Where is it flipping? Okay. I think this is it. Multimeter agrees. Okay, let's get the cap back on. Unfortunately, it's only the only cap that I have for this voltage rating, 24 volts. So I need to reuse it with double X. Okay. I switched the camera so you can see what I'm messing around with here. I'll be back in a minute. And then we should, I'm changing the optocoupler, optoinsulator voltage to 5 volts instead of 24. That should prevent the MOSFET from dying on us. Oh, come on. The ground planes preventing me from soldering that back in. I will just solder it like that to the pads and that will be all. I'm done with this shit. Okay. I give up. Any last suggestions that I should be aware of before we start? Before I burn my fingers even more. Okay, let me test what we got here. This is terrible. Okay. Let's test this with 24 volts, no. 5 volts, yes, okay. Pulse of is around 10 milliseconds. No, it's around 2 milliseconds if we do it right. But currently we don't have a pulse. Let me check. So I'm back. If you have any suggestions what to change and what to test, this is your chance. I'm done with this. Okay. Can we reset column? Okay. Reset column. Reset delay is 10 milliseconds. Set delay. Okay, let's upload this. And let's see if we can get it working. As requested before, please check now what the gate of the MOSFET does. Okay, we can test it before connecting. What should we test there, Anna? Voltage on the gate. Yeah, the gate will be 5 volts. I can test this, but I'm sure because that's what I did the past half hour. I tested it against, this is the gate, this is ground, and it's basically pulsing shortly. I think I will just connect it and you will see what happens. Okay? Okay, moment of truth. Moment of truth. Magic smoke again? Nothing happens. Oh, wait. It's not connected. I disconnected the ground because, yeah, the USB power supply of my soldering iron was zapping me all the time. Okay, again. Are you happy now? Yes! Okay. Okay. Now, can we connect this to the PC without destroying my PC? Now let's I do a 4. Okay. Let me test. Give me a second. Okay. Yeah. Okay. We have some sticking dots here. This one is stuck. No. Do you want more of this sound action? I switched the microphones. Here. Oh, 24 volts now. So it's not the voltage. I think that here's some gun. I can see that. Okay. Okay, fix that. Keep your matrices clean. Burnt in pixels. Okay. Do we want... Okay, now we can work here. So we are setting each dot by itself, but we can use the complete show. This is basically set dot no, it's 15-bit, no, 16-bit, push bits, oh yeah, there is some burn in, I think. Oh, it's too fast. That's crazy. Okay, okay, we need some... The current might be not high enough. No. Oh, the drivers might be overwhelmed. What if we do only every second? Why do I see? I think we might not be able to set the current so fast. So let's do it like that. No, 8 times 2. How many can we set per driver? So, okay, per driver we can set, let's try with 1 pixel per driver at the same time. So we optimizing now. This is, oops. Oh wow, that was bad. That's what's happening. Uh-oh. Okay. Good enough. Good enough. But I think that's it. More current is not possible. We can test it. Yeah. Let me get this board more current. Okay. We are current limiting here. Not current limiting on the board. I think what we can do per driver, we can set 4 pixels per driver at the same time. That's what we can do. Okay, and now remove the delay. Okay. I think we want to reset the row Oh, wow. The row before that. Oh, interesting. Maybe 2 rows up front. Okay, fewer broken pixels. And now we do it like that. How many frames per second? Three frames per second. Oops. Okay, we get broken pixels there. Doesn't change anything. Okay. The driver works. Let me fix one thing here. Ah. This is 5 volts now. And here, right. Before I forget it, that's done. Okay. So night window. Oh, I'm getting headache from this. Okay, let's stop. Ah. I'm wondering if you could reset everything at once or multiple columns at once. We might not want to, but it should be possible. Okay. So let's dot's temperature. Let's test it. Let's check the dot's temperature. 23 degrees. Okay. Now we can fix the show method. The diodes are fine. Let me fix the show method. So show, okay. So last frame, frame count, column count, row count. Do I have specified this like that? Okay, so this needs reset column X. Break now. We can only set 4 per driver, 8 at once, at 8 pixels at once. How do we do this? Okay, let's start with single like let's go step by step and do one by one. So let's set dot X and Y, and that's it. Okay. We don't need that. And this is our oscilloscope. Did it die? Okay, we need the probe. And the best part is that on the Flippy Flip, okay, let me turn that off for now. The best part is on the Flippy Flip, we have a screw terminal for the probe. Woo! So this is what is ground? This is ground. No, this is ground. This is so neat, you are envious now. Most probably. Because I have specifically added 36 analog. I kept it very short and away from any power. And it's a screw terminal directly close to the microcontroller. And now we have our flip dot oscilloscope. Okay, we need to update the code a little bit. Oh wow, the drivers are warm. No, not the drivers, it's the 5-volt regulator who is warm. But anyways, let's do it. Let's turn it on. Okay, how do I measure? What do I measure? Do I measure anything? Do I need the oscilloscope? Give me a battery. Where is the battery? Okay. That doesn't work. It stopped working. Okay, let's check the code if there is something off. What is this clear? Ah, yeah. Oh. Okay, I turn on the generator here. It starts and then it stops. What is wrong with the graph? Okay, we need to change it to call count. Oh, set dot. I will change everything here to be vertical. Yeah, whatever. No, dot is right. Dot. The update rate is slow. Better. Let's make this line continuous, shall we? No. Okay. Crude method. This will be way smaller. Bit doom. What? It didn't do anything. Oh, it's in the first column only, or what? Wait, what? Ah, equals. This was wrong. Oops. Oh, I think we are done here. The Flippy Flip works now. What do you think? We have 5 hours and Flippy Flip worky. Okay, the continuous line looks terrible, but maybe we remove the +1. Yeah, no. We need the 1. Okay. Pink LED! Yoo-hoo! Okay, friends, next time we will utilize this to do whatever. We can do an UDP display that's connected to the chat and you can send pixels or something. A stay success button, yes. Now I need to cut a video and put it on my main channel. Thanks everyone for the help today. Your input was very valuable. Music is over soon and then we can all go to sleep. Bye everyone! Thanks for joining!